Alrighty, so hopefully today's lesson is going to be a quickie, but I finally got a hold of a Renix 2.5 liter automatic transmission ECU. Hooray! This is like damn near the unicorn of the Renix universe. It's really hard to find yourself a 2.5 liter that came with an auto trans. So the reason why I needed specifically an auto trans and not a manual trans is because the pins are different on the Renix block depending if it's a manual or an auto. So when you come over under the hood and you find this guy, the data pins that a scanner uses to communicate with this thing, they change depending on if it's a manual or an auto. I was like, really? That's a load of hooey. With the 4.0 liters, it doesn't matter if it's auto or manual, they use the same thing. So that makes things easy. So I got myself the ECU and it's all hooked up. So let's run you through the system real quick, the big old spaghettios of wires. Alright, so we have a Snap-on MT2500, which can read the data excelente. So I just have myself an old game port adapter, because that's what this is. It's a 15-pin game port adapter, and then this comes out to like a square block, and it's great for these little jumper wires that I have for like breadboard connections, because you can just pop them right in there. Okay, so we have 4 lines that go into the scanner. 3 of these lines are used for data, and then we have the orange wire, which is just the positive, the 12-volt power in. So we have the orange wire is our positive in, our black is our ground, and then we have our 2 other wires, the blue and the yellow, which go to, the yellow one goes to D1, and the blue one goes to D3. So if we were to look at this on our block over here, I think D1 is this one, and D3 is that one, and positive is D4, and ground is D7. Pretty sure. Don't quote me on that. We'll look at a diagram later. Okay, so with those 4 connections hooked up, and actually here, I actually did draw it all out. I sat there and pinned out what the gamepad things go to. So hopefully that gives you an idea. We got D1 and D3. Those are the important ones for data, and then ground is also used for that. So here's that. So these numbers here are what these numbers are here. So this D1 goes to that one. Okay. So with those 4 wires connected, now we have to go over to the ECU side. So how do we know where our diagnostic connector goes to the ECU connector? Well, that's where our wonderful 1990 factory service manual comes into play. So over here we have our 2.5 liter engine controller connector, our ECU. Now this is the connector view, not the ECU view, so make sure you have that in mind. Sure. But the wires that we care about, I figured it out by looking at what the smaller number over here is. That's like the circuit that it goes to. I did some comparisons. So here, let's start at the beginning. Okay. So first off, notice that the connectors are different for the 4.0 and 2.5. They have different things going on. That is important. So in the 2.5, notice down here, D2, the bigger one, pin 1 and pin 3 change depending on whether it's a manual or auto. So if we come over here, you'll notice if it's a manual, it goes to the upshift lamp, and if it's auto, it just says ECU serial data. Down on pin 3, if it's an auto, it goes to the park neutral switch, and if it's a manual, it just says ECU serial data. So that's important. But if we come over here, look at circuit 34, which is a 18 gauge black wire, and then up here circuit 136, which is an 18 gauge pink wire. When we go back over here, you notice for pin 18, we have 136, our 18 gauge pink. ECU pin 12, that's our 34 18 black. So we got our wires there. So now the way that I have this all set up, the first 2 wires are both ground. I don't think you have to actually connect to both, but I just have connected to both. So the first 2 pins, pin 1 and 2, are ground, and that's being fed from our little 12-volt regulated supply over there. And the next one is our our battery positive and our ignition, so 3 and 4. So if you notice, I got the clips set up so that they are touching both terminals, and that goes to our 12-volt supply. So that's the positive power. So to show that off, we have 1 and 2 are power grounds, and 3 and 4 we have ignition and battery. So we need both 3 and 4 on for the ECU to turn on and do all the magic work. So now that means that we have pin 12 goes to D3 and pin 18 goes to D1. So now we can come over to the snap-on scanner and we will go engine, and since this is an automatic, we will go automatic. Yes, data, and hey, look at that, we actually have stuff. Hooray! Ain't that cool? Fun fact with the 2.5 liters, their battery reading is it works all the time. It's off the actual, I guess, one of them input circuits. And we have a prom number of 20E2. Okay, so now we've confirmed that that works. Great, so we have our data. Now we can monitor the lines and figure out what's going on in here. So, if you notice, we have some fancier technology in here. Yes, boys. We're growing. We're becoming great. We have ourselves a Pico scope, a 20-something or other. I don't know. It's the base model. It's like the 2024A, something like that. But anyway, we got 2 probes in here, and it's fast enough for anything I'm ever doing. So, excelente. Plugs into USB, and there is some beta software. Even though it says it's not going to work with Snow Leopard, it actually works with Snow Leopard. It says the minimum requirement was, I think, Mavericks or something, but ain't nobody got time for Mavericks. So looky her. We got ourselves some Duda. Check it, son. That's pretty cool. So, you notice, let's make sure, oh, okay, so both of our lines aren't hooked up, so let's hook up the other line, just so that this can be proper. Come here, baby. Come here. Yes, come here. Okay, so we have our 2 probes on here. We're just on the 1X. They're good up to 20 volts, so we don't have to worry about the 10X. And one of our ground clips is clipped to our common ground that's going throughout the system. So when we come over here, we can see our wonderful data. Yes. So our red line is the actual data stream, and the blue is... I don't know what's going on, but it's required to complete the circuit. You either have to like give it power or ground, or things have to happen with both lines in order to get data. It's kind of goofy. But yeah, we got data. We could come into here, and we could go serial decoding, and we can add a... Come here. We can add a UART, and we are at a custom baud of 62.5 thousand. Everything else is fine. We'll do decimal because I like that. And our data is on channel B. Don't forget that. Okay. And hello? What the fuck? You're making me look dumb now. And we also need ourselves a, I'm just going to put in a 2-volt threshold for that, and the reason for that is because if you look at our signal over here, it's not a true 0. It's actually I don't know what the heck you'd call that. It's not. I don't know if that's a floating ground or what. It's not 0, and that tricked me up before. I had to add a voltage divider to my inverting circuit so that it would actually turn off properly. But anyway, if we come into here and we start this bad boy up, you see, we got the numbers. Yeah, very good. And if I can make this bigger. Oh, yeah. Check it. We got numbers, son. Not a whole lot. Most of them are either 0 or maxed out, but that's because there's no actual sensors hooked up. So cool. We got our data. Excelente. Alright, so now that we can see what the heck's going on there, if you feel like watching it, the 2.5 liter The first 2.5 liter video I made for the manual should give you an idea kind of what's going on, what to expect. But I like to just plug things in, unplug things, and compare and see what it's doing and not doing between the two setups so we can figure out how to copy it. Okay, so the nice thing is that once we can simulate this on the bench, then we can start poking about and see what is actually going on. So I took a number of screenshots. I want to show you real quick what I did to figure out the 2.5 liter manual. So what I did was, here we have our ECU, and we have what it looks like when the MT2500 is on and reading stuff, and what the ECU looks like when the scanner is not plugged in. So the important thing is to compare. So this is what the scanner is doing, and this is what it looks like when the scanner is not plugged in. So by comparing the two, you can see what it used to look like and what's being done to it to make things different. So if we come down to the bottom two, we have our D1 and our D3. So notice that one is over here floating, and the other one is at 5 volts when it's not plugged in. Then when we plug the scanner in, that 5 volts gets pulled to ground. So it was 5, but now it's reading ground. And over here, the pin that used to be floating is now giving us magical data. Now, it's important to know the difference between floating and ground, because these two could be very different things. The reason why these look so goofy is because I was using an Arduino to figure all that out. So that's why it looks like that. So now all we got to do is the same thing again with our scanner. So right now, here is what the ECU looks like with without anything connected. So we still have our 0 line and we have our 5 line. But how can we trust that this line is actually 0, not floating? This is one of the issues. I'm not super keen on oscilloscopes yet. I'm just barely getting the hang of how to kind of use them. But I'm not sure how you can, I guess, not reference ground, because if you unplug the ground clip, everything just goes crazy, even if there's a signal in there. So that's no good. So then what I had to do is whip out the trusty Arduino. So that's what's going on in the background over here. So if we come down here, we have ourselves an Arduino Uno, and all we're doing is we're reading in an analog pin. For us, it's A0. We have our ground clipped over to the ground thing, and you think, oh, that's ground reference, but it's not. Because the interesting thing is, right here is our wire, right? It's not connected to anything. And when we come over here, this thing's going all crazy cattywampus all over the place. If I unplug the wire, it just it slowly drops down to 0. So I don't know if you can see that. That's a 0. But when I plug that wire back in, we get some interference. It's picking up some kind of something or other. It's basically like an antenna. So the cool thing is, we can use this interference to our advantage to figure out if a pin is being brought to ground or not. And that is exactly what I did. Now, the problem with the Arduino, for this, since it's a stock Uno, it's only good up to 5 volts. You can't feed it any more than 5 volts. And if you go down to some of the faster stuff, like the Teensies, those are only good up to 3.3 volts, so you gotta be real careful with them. Now, personally, I've found out that you can put 5 volts to them accidentally, and they don't die, so that's good. But it's highly unrecommended. The 3.2s are 5 volt tolerant on the digital, but on analog they still claim it's only 3.3, so don't push your luck there. But that is important, because if we look into our protocols over here, there are a few things. So, this is what the snap-on scanner looks like when we tell it to read and there's no ECU connected. Notice one of the lines is being pulled up to battery voltage. It's getting pulled all the way up to like 13, 14 volts. You can't put that on an Arduino. So what I used to do before is make a voltage divider so that we could read that in safely, but then the problem is you can't tell if things are floating because it's being brought to ground. So this only works if the signal is less than 5 volts, which Once we start poking around, we can find that out. So let's bring this all together and do some comparing between everything. So first off, this is what the scanner looks like when it's trying to read an automatic transmission ECU. And this is what it looks like when it reads a manual. Notice it is exactly the same. Both lines look like they're doing the same thing. Let's see, which one's which? So for reference, all of these, our red line is D1 and our blue line is D3. So here, D1 is brought to 12 volts, and D3 looks like it's ground. And same with here. D1, 12, D3 looks like it's ground. Cool. So now we know that we can safely poke D3 with the Arduino. So now that's exactly what we're going to do. So with the scanner hooked up in the same situation, now we're going to use the Arduino to figure out what we find. So, remember how it looked like it was 0? It was not. So when it was when we tell it to read in the automatic transmission, the line sort of kind of floats around, 2-3 volts. That might even be negative. I hope it's not. But when we come over to the manual, notice that is actually 0. See how the thing shifted? This is actually 0. So we can tell on the manual version it's pulling it to 0, down to ground, but on automatic it kind of floats around. So that is a very important distinction. Alright, so real quick, we're going to do the same thing with the ECU as well. So this is with our Arduino. Since we know from the oscilloscope that we get 5 volts and 0 volts, we can now poke it with the Arduino. So now, let's do that with the Arduino. So with the Arduino, you notice that the one that looked like it was 0 kind of does some weird jumping up and down, kind of like it's at 0 and then it floats, and then 0 and then floats, is what that's kind of happening. And on the other one, notice it's a perfect 5 volts. So we can tell the ECU is pulling high, and then the other one is kind of like a pulsing low, which is interesting. And it's stuff like that you might not catch on an oscilloscope unless you can figure out how to do this without ground referencing or whatever the heck that's called. I don't know. I'm kind of using some questionable principles here, but it helps me with my work. So now that we've found out what everything does, let's see what it looks like. Alright, so now when we come into here, with all this background knowledge, let's try to bring this all together. So we know that the scanner is pulling this thing to 12 volts, and on the Arduino, we noticed that it was pulling low and then kind of floating. Well, if you put those two together, when it's floating, the scanner brings it to 12 volts. But then when we read like actual ground, that's when the ECU is bringing it low. So our scanner pulls the line high, and the ECU pulls the line low to make our data. So that one's good. Now on the other signal, the blue one, notice that's sitting at 5 volts. When we probe the ECU by itself, it only read 5 volts. And since it's still 5 volts, we can see that the scanner's not doing anything to that line. Now, look what happens when I tell it that it's a manual trans ECU. Same thing on the data line. Notice how our data is still 12 volts to 1 volt, but our blue line is now brought to ground. So when we tell it it's a manual, it's pulling that line low. But when it's an auto, it doesn't pull the line low. And that is probably something to do with the transmission switch. So if we go back over to here, remember, so that was our pin 12 on the ECU is D3. So when we come over to D3, you notice on this it's labeled as park or neutral on the auto. So let's see what that's doing. Let's go take a look at the document into a diagram. Okay, so let's come down to the bottom here. This is our ECU, okay, and we notice we have pin 12, and it does different things for different ECUs. So on a manual, this goes straight to D3, no problem. Okay, cool. But on the auto, it goes to a splice. So this splice goes over to here, and it actually sprawls across 2 different pages. Then this splice then goes back to D3, so we know that that's good. So this is still going to D3, that's not an issue, but it goes to a couple different things. Alright, so let's start over here. First off, we notice that this pin does something different for an auto trans and a manual trans. If this is manual, then that goes straight to ground, great. If this is auto, then instead it runs off to something different. And that is for the starter relay. Okay, so this is for the ignition switch. So this is our park neutral. Okay, I get it now. This is making sense. Alright, so check this out. So right now we have ignition hot over here, and what happens is we have our coil that closes our starter relay. So when we're trying to start the engine, if it's a manual, it doesn't care. It'll start no matter what, no problems, because our signal is able to go straight to ground. That's it. It just goes straight to ground, no problem. But on the auto, there's a safety switch so that you have to be in park or neutral for it to start. So instead what it does is it veers off here, okay, and it goes over to this connector. So we have our B and our C. Okay, so if B and C get jumped, then great, it goes straight to ground, and then our ignition coil can do its business. So on this side we have B and C again. Our B goes to this side of the switch, and our C goes to the other side of the switch. So that is our park or neutral switch. So that's how that works. Interesting. So that will drop that down. So that's why that's doing that. But to bring this all home, if the scanner were to pull this line low, then the car would think that it's in park or neutral and then try to start. And you don't want that. So it just doesn't do that. But on this side, it does bring it low. But these aren't connected, so remember that. So that's okay, so that's what's going here. Because remember, on the auto side, this goes to D23, but on the manual side, this does not. It's just a ground, and the manual D23 just goes straight from the ECU to here, so we have to drop that. Okay, now this is actually making sense to me, too. Cool. So what all this really means is basically, in order to read the auto trans, all we got to do is the same as the manual trans. We just don't have to ground the line. So we still have to provide ourselves a high signal so that the ECU can bring it low. And we also need to use our voltage divider so that we can properly get a low signal out of our inverting transistor. Because if you notice, our line is idling low and rises high. That's not how UART normally works. Usually it idles high and data goes low. So we're inverting that with a transistor over yonder. Come into the beautiful book of magic. So right here we had D3. So on the manual we were pulling it to ground. I wasn't sure if I should use a resistor or not, and I definitely want to put one on there for safety. But we had to have our TX line, which gets pulled up with a 3.3K resistor. I don't know how much that resistor value really matters. All that does is change the rise time and the distance you can stuff, and I don't know, whatever. Okay, so that's great. But the problem is, since we don't have that zero, our inverting transistor will never shut off. Because even when it's low, it's still 1 volt, and our transistor has a turn-on voltage of like 0.6 to 0.8, so 1's above that, so the transistor was always on. So my fix for that was to make a simple voltage divider. So we get a 4.7 here and a 2.2, and what that does is get our readings real close. So it brings it down to our high voltage of 5 volts comes down to like 1.6 volts, and our other one comes down to like 0.3. So this does two things. First, it fixes our signal so that it actually works, but two, it kind of helps us with interference a little bit. So it brings our ranges to the middle of the transistor flippy-floppy. So since our flip-flop is at like 0.8, we have 0.3 and 1.6 as our high and our low. So that brings us closer to the middle mark of our transistor flipper. Instead of before, when we were at 0 to 5, our flip is way down at the bottom. So there's this little tiny section here that's off and the rest of it's on. So it's a little better for that. So anyway, our fix, so to read the auto, I think all we got to do is turn that off. And it should be good, because we don't have to worry about the line. So the cool thing is, on the connector that I made for this, we had a switch added. So all that this does is when you flip this switch, D3 is getting shorted to ground. That's it. That's all it does. Everything else is still the same. So I should probably add a resistor on there just for safety. Now here's the interesting thing. Let's find out what D3 does for the 4.0, because otherwise why wouldn't I just have that grounded all the time? Why even bother with the switch? Well, first, I'm glad I bothered with the switch, because this will save us for our auto pals. But second, if we go over here to our 4.0 diagnostic connector, come on, D3 is our B positive latch relay coil ground. So what that means is our B positive latch, I think that is the latch that turns on with the ignition. That, like, this is our ignition relay. This turns all of our ignition business on. And the ground means that if we were to ground this, it turns the relay on. So I actually tried this on my vehicle just to see what happens on the 4.0. So when you flip this switch like this and we're grounding D3, all it does is it turns that relay on. And if you flip it back, it turns it off. So it's not the end of the world. But I might add a diode in there, or add some resistance in there, just in case. Okay. And the other issue is this is kind of untested, so maybe I should hook up our scanner, our little REMs, and see if that works. What do you think? You want to do that? Let's do that. Okay, so here we got some serious moment of truth right here. So if you notice, our switch is in the 4.0 mode, which means that D3 is not being grounded. And we just have D1 and D3 running over to our ECU. So D3 is 12 and D1 is 18. Okay, so now we will plug in our REM. I'm just going to power it off USB for now. And alright, it didn't switch to data mode, so let's go to vehicle, change this to our 2.5 liter, and possibly have data? I don't know how we could... oh wait, we can check voltage. Alright, let's go to battery voltage. Only reads 8 volts. That's not good. Alright, let's unplug that. Plug that back in. Interesting, we're not getting any data. I wonder why. Let's hook up the oscilloscope. Just as a quick test, I wanted to try something here, so check this business out. Right now, for D, since we found out that that pin isn't being grounded, I want to test the snap-on scanner and see if it actually needs D3. And would you look at that? Right now, D3 goes to that blue wire, and our blue wire is currently not hooked up to that, but we still get data. Awesome. And just to prove it, if we unplug D1 over here, unplug, notice it gives us an error, no communications, key on. Plug it back in, and data's back. Okay, so for the automatics, we only need our 3 regular pins. Cool, so that is a very good sign. So now, I guess we still need to go to the oscilloscope to see what the heck this is doing or not doing. You ever just get to the point that you're so smart that you're stupid? Hello, we're forgetting a key component here. We need the ground as well as the data, goofball. Check it. We have voltage now. Yeah, buddy. Oh, fuck yeah. So that's it. Cool. We're already in the money. Look at that. We had compatibility and we didn't even know it. Oh man, that's the best feeling ever. Sweet. Alright. Well, that's cool. So, yeah, hopefully that makes a sense to you. If not, well, I don't know. Figure it out. Oh, but that's tits, man. That's cool as shit. We're in there, dog. We're in there like swimwear. Oh man, that is fucking awesome. Sweet baby Jesus. Okay, well, yeah, I hope you learned something through all this babbling. If anything, that sometimes things just work out. And sometimes you just wonder what the heck is going through that engineer's mind when he decided he was going to change pins based on the transmission of the vehicle. Okay, so as one final hurrah, we just got our ohms meter hooked up over here, and we're probing D3. So on the auto mode, you notice we have no connection, and even if I turn that all the way up to 40 million, we got out of limits, overload, whatever you want. So we switch this back over to our manual mode, and now we get about 130 ohms. So that's good to know. So here it is, the beautiful final circuit. So everything is as pictured here. And notice over here, for auto trans, this guy over here is not connected. D3 can just, go float off in the wind. But for manual transmission, you can short it to ground if you like. I haven't had any issues with it. But the scanner shows about 130 ohms. So, just for safety's sake, you could do that if you like. Alright, so there you go. That's how you read your 2.5 liter Renix business. And if you want the 4.0, it's the same thing as the automatic. It's this exact same circuit without this resistor. So D3 is not important. There you go. That's how she do it. And if that clears anything up for you, you can see our simple 4.0 liter circuit, which is just a pull-up that goes to a transistor, easy beans. Over here we have our pull-up, but we also have the voltage divider so that the zero can come down low enough for the transistor to shut off, along with this resistor, only for manual. And transmission, even easier, just needs some kind of pull-up, 1K or whatever really, just has to be strong enough to go the distance you want. Good to go. Alright, that's all the magic right there. Just to check everything out, since we do have all this fancy dancy technology, I decided to come out to the 2.5 liter manual transmission and just poke about with the oscilloscope. So there's something weird going on here. You notice we have our data, but the scanner isn't plugged in. What? So all that's going on here is we have our switch on down here, so D3 is being grounded. So if we turn the switch off, this is what the ECU looks like when it's, everything should be disconnected. What on earth is going on here? So if you notice, the blue line is pulled up to 5 volts, and the red line's pulled up to battery voltage, which is like 11 volts. The battery's a little low. Okay, so let's do something here. Red is channel 2, which is purple. Purple is yellow, so that's D1. So red is D1 and blue is D3. So for some reason D1 is being pulled up to 12 volts or battery voltage. But it's weird because I took a different shot that showed what I was expecting before, where D1 was at 0 and D3 was at 5. So why all of a sudden now is this thing at battery voltage? I don't get it. This is a new what the heck. So without any pull-ups, the ECU is doing the pulling up. Just by having that switch grounded, now we get data. Dude, what? What is this? The weird thing is that this thing should be pulling the line high to 5 volts. Now, since we have a transistor and we have a voltage divider, anything higher should go to ground, so we should be safe, luckily. So if we plug this guy in, right, we get our data, okay, Everything still works. And that's still going. But if we turn this off, the switch off, we lose our data, and it's still floating at, 11 volts. So let's see what happens when we unplug it real quick. See, it went up just a hair, so that's probably from the internal pull-down resistor. But I don't get it. Oh dear Lord, I don't understand technology sometimes. So yeah, that's something. That's really something. So it works, but it's one of those, I don't know why it works. Okay. Yeah, and the scanner basically showed the same thing, so yeah, alright. Well, great. Got more questions than answers now. If it ain't broke, don't fix it. That's all for now. Okay, the plot thickens. So, you ready? I want to try something. I got an idea. So this right here is our... Shut up! So over here is our shift lamp plug. So we're going to unplug that, right? We're going to unplug this bad boy. Come on. Out you come. That thing's going to hurt. Come on. Okay. Alright, that didn't do what I was expecting at all. So this is what we're used to. Is the key on still? Okay, the key is on, and we got that. So that's what we're used to. Now, I am going to take it out of fourth, okay? Because before, when I was testing that, we were in neutral. So our shift lamp is off, and I can't tell if it's on now. I don't think it is. It shouldn't be if the thing is open. Okay, so now that's still reading what we expect. Great, okay. Let's plug this back in. Whoa, look at that. She just jumped to 12 volts. So maybe that's what's going on. Something to do with the shift lamp. So the shift lamp is raising our voltage high. What on earth is going on here? Yeah, so you see that that's running at battery voltage. Let me come over here and why can't I see it? Let's go around. No. What the heck? The light's not on. Usually it's on. But when we put it into fourth, I think that there's some kind of switch that turns that thing off. Because every time you put it into fourth, the light goes off. And then look. Alright, I'm confusing myself more than this is helping now. So now that we have this, like that, now let's plug in our REM. And our switch is also... Okay, our switch was off. So now we have these two voltages here. And if we flip the switch, so we have our three line high, if we flip this, then we get our little bits of data. Huh. And if we take it out of gear, then it jumps up to 12 volts. So something with that shift light is messing with this thing, man. Okay. So now let's see what happens when we unplug this. Hey, look at that. It drops back down. Okay, so it is something to do with the shift lamp as well. This is some weird stuff. Like why would you do any of this? This is so goofy. Okay, well that's a thing. That is certainly a thing. Oh man, Renix, it will never cease to amaze me.